pan na natin yung mga videos. Hopefully nalantaw ninyo, no? Tapos, tagalan link. I think,
Wa pa na ako magtanaw sa
wala pa niyo nakuan? Wala pa niyo na maglantaw? So, dapat kay, ang coverage magod sa midterm na to kay up to Newton's laws. So, you have to study those videos na ako ang gihatag previously katong ay Newton's laws po. So far, ang na-take up na nato nga mga topics, I mean, na-forward na ko nga mga topics kay we have vectors, and then one-dimensional motion, and then you have two-dimensional motion, dayon na uniform circular motion, and lastly, the Newton's laws. So I think this evening we will upload the topic on work and energy. So the work and energy will be the first topic to be included in the final exam. So mga final coverage. So probably if we can lain na po guys sa mga part good nga morbitag ko magatang exam na walay consultation about those topics nga akong ipang-upload. So that's why as much as possible I want to hear from you if what are the common misconceptions or common na mga problems nga na-encounter ninyo when you watch those videos. Okay? So, kamusta man? Kamusta ang I mean, pila ka book pa ang wala naglantaw sa Newton's laws. Dugi-dugi na pagpena ko to gi-upload to one Newton's laws November 5. Today is November what's the date today? November 10? So
Yes,
5.
sir.
So now, ang atong discussions lang kay taman ra ta sa atong consultations taman lang ta sa one-dimensional pa ata, no?
Yes, sir.
Okay.
No.
Okay, class. Kung saan gusto niya i-clarify?
May klase to sa ganun to.
Good morning, sir.
Hi, good morning. So, ang akong magdawanonan karot kay dili na nako i-thorough ang discussion sa consultations about atong tanan nga wala na discuss pa nato, like ay wala nato na discuss sa consultations, like ang atong sa tawagan ni you have threefold two-dimensional motion, and then you have uniform circular motion and Newton's laws. So ang ako ang purpose lang is gusto nato nga if na may questions any of those topics atong i-take up para at least ma-address na ko ba kung asa dapita ang libog dito nga part. Kaya kung i-discuss pa na ko tag sa padulong dito madugay class abtan tao si tawagan na abtan siguro tao ganang end of November kung ano pa nato. That's why akong si tawagan niya ko ang objective ta is when I gave those videos and then you watch them, and then if na ay si tawagan ni na ay clarifications and questions na gusto ninyo i-raise, so you can raise it now. So, nag-practice ba mo sa kanang kwan? Nag-practice ba mo sa exercises nga naa sa main reference na to?
Sir nga,
Ah?
ato nga reference, sir.
Katong kwan, University Physics nga book. Na may mga exercises na dito.
Wala para ba, sir?
Okay, so dapat kay ko, no? So, mo ni siya kwan karon mo ni siya problema sa kanang kuan sa online online class. Kay kuan ba? So, paano to niya? Sige, murag ka lang kuan. Gusto lang na ko may balaan kung asa na mo ko to. Lahi mo gud pacing ka class na ay siguro isa sa inyo ha ay naay uban sa inyo ha nag-study na napoy uban nga wala lang tawang videos. Si manay problema karon. So lisod siya pagka nang kwan pag-balance if ever sa tawag gani. Naay ganun koan naay bal extremes ba. So ang uban kay mo nagkuan lang nagtagad lang sa consultation. So asa na consultation so dito lang pud na topics. But then ang purpose unta nato sa consultations is clarifications regarding sa mga videos nga na-upload. So mo purpose sa tawag ana sa consultation class meetings. Anyways, so iyo ka ako mag-start. Kasi una mga tana. I mean, dapat mangutana mo class kay kung dili mo mangutana sa ato, siya siguro i-postpone and then you watch those videos nga ako ang gipang hatag previously.
Sir,
Yes.
regarding sa katong one day sir ba?
Yes.
First derivative yun ang formula sa velocity tas acceleration din second derivative.
Yes. Yes, that's correct.
So magsunod re lugar to sila sir. Like for example, di ba pagkuhaon nimo ang first derivative ay second derivative gamiton nimo ang first derivative. So murag kuan na sila
Mm.
sunod.
Yes. Yes. That's correct. So okay, i-share na ko ang screen na. Okay. I-share the screen para ma-explain ako ang let me show you. Remember the okay, so also recap. Remember that in one-dimensional motion, you have the following equations of motion. So we have, for example, first equation is you have V plus VO plus AT, right? And then you have X minus X sub 0 equals VOP plus 1/2 AT squared. And then you have x minus x of 0 equals 1/2 VO plus V times time. And then the last one would be you have V squared minus VO squared equals 2A x minus x of 0. Now, let me name these equations. This would be equation number 1, equation number 2, equation number 3, and equation number 4. So, you have to remember that ini nga equation, kay gamito nato ni for objects na moving with constant acceleration. Okay? So you cannot use these equations whenever the acceleration is not constant. You have to remember that. So now, going back to the questions earlier by si Kyla ba to, no? Miss Kyla,
Yes, sir.
yes, di ba? Ana si Kyla, sir, ang velocity ba, iyang pangutana kay sir, kung ang velocity ba kay first derivative sa imo position, and then ang imong acceleration kay second derivative sa imong position with respect to time. So muna yung pangutana. Okay? So now, akong buhaton kay, okay. So, let's try to answer this. If ever gamito na tong equation number, okay, so let us use this equation number 1. So let's verify equation number 2 lang. Okay. Let us use equation 2 sa equations of motion. So you have kay x minus x of 0 equals VOT plus 1/2 AT squared. Okay? So now, what if we take the derivative of equation number 2. So remember, this is equation number 2, right? This is equation number 2. That one. So now, kung quantum derivative, so that would mean, okay, let us take the derivative both sides. So you have derivative of x minus x of 0 equals VOP plus 1/2 AT squared. Okay? So I'm gonna pa sa button na take the derivative of equation number 2. Can you follow?
Yes, sir.
Yes.
Okay, so
Yes,
now
sir.
let's continue. What we're going to do is, okay, let's distribute this. Let's distribute the derivative. So that would mean I could have derivative of the left-hand side, and then I have the derivative of the right-hand side. Are you with me?
Yes,
sir.
sir.
Yes, sir.
Okay, now you have to remember, you have to take note that note. Okay, the following parameters are constant. The following parameters or variables class. Okay. So this x sub 0 is a AC constant, no? That's a number. So kini siya, we denote this one. Remember, this is the initial position. Okay? Also, ang kining x, kay kuha na siya, mura na siya function, no? Murag function ng x. So mag-change na siya with time. This x sub 0 will not change in time. Kuha? That's why mo na siya constants. Gitreat na to siya constants kay as time evolve, those parameters will never change. Okay? The same with the initial speed. Yes, initial speed or velocity. So initial speed. Okay? Are you with me?
Yes.
Yes, sir.
Yes, sir.
All right. So 1/2 is just a number. And then, of course, ang acceleration, in this case, acceleration is also a constant. So because ang ato ang equation number 2 is from the equations of motion wherein we consider constant acceleration. So that would mean acceleration is constant. Okay? So those are the constants. Now, ako ning pangalan ni siya og 2 star equation 2 star. Okay. Now, equation 2 star becomes, so what we are going to do is perform now the corresponding derivatives. So here, kabalo man ta class now, derivative of, so naman kay, sa left hand side, pwede na ako na i-distribute, di ba? So na ako dx dt, and then minus dx sub 0 dt. Okay? Kuha ninyo? Ay, pangit mo pagkasunod sa akin na lang. Mas masapkan ninyo. Ako ddt x and then minus dt x sub 0. That's the left hand side. Initial class. What?
Yes, sir.
Yes, sir.
It's important nga mapalo ninyo. So, ako ra sa gibot na ako class, igoro na ako gi-distribute na. Igoro na ako gi-distribute. Okay? And then, left hand side, no? That's the left hand side. Now, how about the right hand side? So I have d dt vo t plus d dt 1/2 a t square. Tama?
Yes, sir.
Okay, so now, remember, x sub 0 is a constant. Okay, parameters are constant, di ba? X sub 0, v sub 0, and acceleration are just constant. So meaning, the derivative of this is 0. Anong 0?
Kay constant.
Yes. So derivative of constant is 0. So that's why that's 0. Now, okay, let's look at the right hand side. Now, the right hand side, we have ang first term, ang VO is a constant, right? Right? This is a constant. Nakuha?
Yes, sir.
Yes, sir.
Okay. So now, what is the derivative of this? So So meaning constant man, pwede man ako na ipagawas na. So I can further simplify this into this one, d dt of time. Plus, this one is a number. A is also a constant as defined at the top here. Is a constant. So I can also take acceleration outside. So that would mean I could write the second term as this. You have d dt, and then I have t squared. Can you follow?
Yes, sir.
Yes, sir.
Okay. So now, let's continue. I have VO here, so I have VO. What is the derivative of T?
1, sir. 1t.
So this is just equal to 1. So basically 1 times VO is just VO, right? Tama? So
Sir.
I sulat lang siguro na sige, derivative of this is 1. So you have that. Plus I have to copy 1/2 A. What is the derivative of this?
2t, sir.
2t, very good. So you have 2t. Now, how about sa left-hand side? Ang nabiling kinala ng dx. What is dx dt?
1.
That's dx dt, right? Okay, so dili pa niya ma-recognize. Sige, ako sa sanikuan. Let's simplify the right-hand side. The right-hand side, first term is VO times 1. What's VO times 1? That's VO. All right?
Yes, sir.
Okay, so now, plus, I have here 1/2. Na speaker na naka-open. Sorry, I have here 1/2. I have here 2. So I can cancel out 2. This is in the numerator. This is in the denominator. Tama? So I have
Yes, sir.
A times t that becomes
Sure.
AT. Can you recall this? What's this?
First equation, sir.
First equation. So let's try to look at the first equation. At the first equation. This is the first equation. Okay? So this one, if makita ni mo ni unsay but mo sa buto ni, this is just equal to V, right? So now let's try to look at this one. So basically, this one here is just equal to V. And what is the left-hand side? That's just dx dt. So this is the question of Miss Kyla. Ako nga. Ayan pangunta na sir,
Yes, sir.
ang speed bagyod or ang velocity bagyod kay derivative sa position. And now we have seen that this is exactly the definition of velocity. Okay, derives from the motion with constant acceleration. Saka lang pong ipakita lang to. Okay, so now how about the acceleration? Okay, let's do that. Let's continue. So next question is, what if? Okay, what if we take second order derivative or differentiation? Not derivation. Second order derivative of equation number 2. So that would mean na ako'y d square dt square na ako'y x minus x of 0 and then equals d square dt square of VO t plus 1/2 AT square. Tama? Equation number 2 is skinny, di ba? Pakita na ko ha. This is equation number 2. This one. That's equation number 2. Okay. So, lantaw diri, ang atong gibuhat primero kay kuha na to ang first derivative. Right? So that's why na first order nga derivative sa imo ang equation number 2. Now, sunod atong buhaton is anak ko nga second order na pala ato na pong buhaton ng second order derivative. Second order derivative. Sir, di man na para sa ganina, murag niambak naman ka. Okay, so ipakita na ko kung sa sinugdanan ana, ang pinakasinugdanan ana kay kini. So, before ana nga line so na ay dapat inani class d squared dt squared and you have x minus x sub 0 equals VOT plus 1/2 AT squared. Okay? Then pagkahuman na ang linya, mo na din i-distribute. Okay? Yambak na ko isa ka step na. Okay? Are you with me?
Yes, sir.
Yes, sir.
Okay.
Yes, sir.
Okay. Okay, so now kung kumuha na ta nga, okay. Notice, okay, notice. Kung ako ning buhaton class d dt and then I have d dt of x minus x sub 0 plus VOT plus 1/2 AT squared. This one, ako rin nagiri right now. Ako rin nagiri right into this. Dua, DDT. Ha? Kini siya nga form,
Yes, sir.
kini siya nga form o kini sila nga form here. Kay parehas na sila. Equal na. Okay, nag-distribute na dayon siya. Nag-distribute na sa left o sa right. Now, what I'm going to show is that I want to emphasize that we have actually performed this earlier. Are you with me?
Yes, sir.
Yes, sir.
Yes, sir.
Anong green?
sir.
Gibuhat na ng green na adrio, kini oh. This one. Kini, ang kulura green ha. This one. Mo na tong gibuhat. So yung resulta gani, ang resulta niya kay
Equation 1.
kini ang imuhang equation na buhat kini. So, ako ni pangalan ni siya og 1 ino. Okay. So, ako lang gamiton. So, this is dx dt, right? dot. So, let me do that. So, remember, this one, okay, kopya lang sana ko d dt. Gamit lang na yung color para di ko malibog. So, ako buhaton. Kopyahon lang ako ni. Ako ni kopyahon. Copy. Copy. So that's actually dt. Now, this one, kining green, okay, ako isulod sa parenthesis, and we know that this is, ang resulta na kaganina is dx dt equals v, pangit akong pagsulat sa v, so yeah, v, vo plus at. Tama? This one. Moni, di ba? Di ba? Are you with me?
Yes, sir.
Yes, sir, boss.
Yes, sir.
Okay, so now, what I'm going to do is distribute this and distribute to the left. to the right. So that would mean I have d dt of dx dt, and I have d dt vo plus at. Okay? Now, what I'm going to do is distribute again. I have d dt of vo plus d dt of at. Now, again, vo is a constant, so that would mean the derivative of a constant is 0. Are you with me?
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Okay, so now, then we know also that acceleration is a constant. So meaning I can take that out. I can take this out of the derivative. So that would mean I can rewrite this term here. I can rewrite that into a d dt of t. So now what is the derivative of d dt of t? What's the derivative? What's the derivative of this?
1, sir.
1. Okay, so
1, sir.
I just copy a times 1. A times 1 is just a. Okay? So the right-hand side is equal to a. How about this? I can simply multiply that would mean murag multiply lang ang murag ng panba, but then so you have to take note that that's the second or that's the second order differentiation of the position, and that should be equal to the acceleration. So mo na itong claim ka ganina, mo na itong pangutanan. Ay, pangutanan ni Kyla. Sir, ang acceleration is kwan ba gyud? Second order ba gyud sa second order derivative sa position with respect to time. So yes, that's this is the proof of that. Okay? So muna itong pangutanan na earlier, ako ipakita lang sa taas. Muna itong gusto may balaan. Here. Okay? So now, kita ninyo nga sa ubos. Okay. This is the acceleration. Indeed, that's the acceleration is a second order derivative with respect to time. Second order derivative of the position with respect to time. And the velocity is the first order derivative of the position with respect to time. Okay. So that's the answers to the question of Ms. Kyla. Any other questions?
Sir, na ko ibang sir.
Yes, Albert.
Muabot pa ba na siya sa third to fourth order derivative, sir? Napa ba siya possible mahitabo na, sir?
Kung kuhaan mo third order derivative, wala na kayo makuha sa imong equations. Okay? So notice kung i-perform, kung kuhaan pa nimo siya o third order derivative, so mabilin kay wala na, zero na. Anong zero naman, Albert? So, curious na si Warbit. Curious na si ano? Curious.
Curious
Curiosity.
sir.
Okay, what's the meaning if na ay na kay third order derivative of the position? Haba na meaning, haba na sense. So now we can rewrite this as d dt of d squared x dt squared. So that's the meaning of that third order, di ba? And we've learned about d squared x d, di ba? D squared x dt squared is, this is just a acceleration, di ba? So I can rewrite this as, I can rewrite that as d dt. Happy na ako. And then I know that this expression inside the parentheses is just the acceleration. Tama, Albert?
Yes, sir.
Okay. What's the derivative of the acceleration? Ang acceleration is, ha?
0, sir.
Zero, sir.
Zero, sir.
Zero. Anong zero man?
Constant.
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 Very good. So, since A is a constant, so derivative of constant is zero. So, walay sense. So, that's why, answer sa iyong pangatang Albert is walay sense. Wala kayo information makuha. Because, third order.
Hindi siya sa calculus na sir kay na kailangan mo bang itaguan sir ang derivative.
Yes. Yes.
Oo,
Sa
sir.
yes, sa math, you can always perform higher order differentiation. But, you see now, sa physics, kay butangan na itong meaning, what's the meaning, what's the sense of doing that certain or performing certain mathematics. So, in this case, just for curiosity, ato lang gilang tao kung unsay may tabo sa leso ay wala zero. So, walay meaning. Wala kayo makuha. Acceleration. Yung makuha is just acceleration is constant. Hindi
Okay.
siguro nakuha ni mo nga ang indeed the acceleration is constant. Zero. Kung buhatan pa nimo na, kung kuhaan pa pwede mo ng fourth order differentiation, wala na kayo makuha kay nag-zero na siya sa third order. So, basically, as you go or perform higher order derivatives than 3, mag-zero na siya. So, fourth order, fifth order, sixth order, zero na ay mo mga makuha dito. Kaya nag-zero naman siya sa 3 pa lang.
Thank you sir,
Diba?
thank you sir. Yes sir, thank you.
Okay. So, at least, di ba, na ay questions na murag makakuan po sa tawag si tawagan ni out of curiosity natin makuha something ba. Now, isa pa line na ay pangutana. Morte man ano yung class? Equations of motion pag constant acceleration na upat. And then, kung tigaan ka o position with this na kay expression, na kay function. Sa batang tag-function, no? Function of the position with respect to time. So, kabalo ka na kay x of t. X of t is equal to blah, 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 blah. So, you can always calculate for the velocity. That's just dx dt. And then you can also calculate the acceleration, that's second order differentiation of the position with respect to time. Okay?
Nakipangutana sir.
Yes. Okay. Notahan na, Ms. Lumingkit.
Sir, kanang kung kuan daw sir, kung para bitaw kanang medyo malibog lang mag sir kung puro ra bitaw sa kaning mura ra bitaw siya mga equation lang tanan kung kuan daw sir, kung try gid kanang example gid bitaw daw sir. Kana na lagi siya.
Gibuhat naman nato, I think gibuhat nato na sa last time. Wala na ako na-upload pa.
Murag na late.
Yes,
Murag
na
late ko ato sir, wala ko naka-upload.
yes, na ay discussions na mo last time nga nangayog example about ani na expression. I think yes, ako lang i-upload siguro later or tomorrow. Na-discuss na mo na siya. So, i-open ako ha. Can remember mo ni I think 7 plus rotation. Okay. Check na to ha. Daily 7. I think 6 or 5. Ako na sa ikaw na browse. Okay. Kita kani? Kita kaning kini?
Yes, sir.
Nakita ba niyo ang cursor? Kining na ay x of t is equal to a plus bt square. And then,
Yes, sir.
Yes, sir.
morning
Yes,
example
sir.
lang, gusto may balaan ni Connie, lumingkit no. So, here, look at that. Ipangita na to acceleration. And acceleration is, we know that that's just second order. So second order differentiation, that's we try to solve for the corresponding expressions of first order derivative. Gibuhat naman natin ang first order derivative here. First order derivative, that's the velocity, that's just equal to 2bt. Here, since nakiblo naman ka nga, this is just the velocity, this is velocity which is equal to 2bt. And then, perform the corresponding differentiation 2b. So we have this one, derivative of time, is just equal to 1. So that's why you have 2b times 1. Here. That's 2b times 1 or just equal to 2b. So ang kining example kay ang b is equal to 5 meter per second square man. So you can actually calculate for the corresponding acceleration to be this. Right, just plug in. So the acceleration is 10 meters per second square. Okay, so muna ikuan Miss Lumingkit, we've done this already in our 6th consultation. Although wala na ako na-upload pa ang 6th consultation na recordings. Kaya I think murag 5th lang ata ako na pa-upload pa. Maybe I'll upload it later. But you can also check, or when I uploaded the recordings on the 6 consultations, you can study it, and then you can have, or you can practice the reference that I gave. So kita ang reference gani katong University Physics na book. University Physics book. Di ba? Naghatag og link ana sa inyo ang kwan diri sa Google Classroom, na link ana para ma-download niyo ang book. And I think kita na po na ako sa inyo ang dagway sa book, right?
Yes, sir.
Yes, sir.
Nasa siya sa first.
Yes. So naay mga kwan to, naay mga exercise step to. Mo siya pwede ninyo ano. Asa naman mo sa inyo ang calculus karon?
Increasing extrema pamanta, sir.
So
Normally.
related rates ba, or minimum maximum ana?
Minimum, maximum pa ata to, sir.
Okay, so after that is related rates. So wala pa may kwan, wala pa may integration na?
Wala pa, sir.
Wala pa.
Wala
Okay,
pa.
thank you. What if sa tayo pangutanan ni Kwan, Miss Bulado, sige daw. Nasa chat, no? Stop sharing. Okay. Sa tayo pangutanan niya, what? Nasa chat, maulag pangutanan na siya. Say, una sa na kay Sheila, kaya na po dahil chat si, na po letter si Kuan Warren. Sir, what if acceleration is daily constant? Yes, that's okay. That's a good question. Unsa nga equation namong gamiton kay ana ka kanang equations ginagamit lang kung ang object moving with constant acceleration. Okay, so that's a good point. That's why I asked you earlier if naana ba mo share sa nako. If naana ba mo or asa na mo sa calculus ninyo. Okay, you know what, if dili constant ang acceleration, so basically dili nimo pwede gamiton tong equations of motions kaganina, o upat ka equations of motions, you cannot use those equations. But what you can do is that this definition, okay, this definition here, I highlight this one, this is always true. Okay? This is always true. Now, in most cases, tigaan lang mo one class, tigaan mo o certain conditions, like for example, tigaan mo either expression sa position, either expression sa velocity, okay, as a function of time, and then tigaan pud mo either acceleration as a function of time, and then pangatan-on din mo yung class of any informations na gusto niya may balaan, like position, etc. blah blah blah. But to do that, kinahanglan nimo og concept sa inyong calculus, which is actually basic integration. Basic integration. I think okay, maybe we can I can introduce you to this. So ako lang buhaton is dili ko mo dive sa math, but then ako lang i-introduce niya unsay buhaton sa basic integration, just like how you perform basic derivative. Okay? Now, okay na ba muna?
Okay na, sir.
Yes, sir.